Hi everyone, and welcome to 4.3, which is concerning the binomial distribution. So let's get started. Okay, so we're going to talk, let's do an example. Let's talk about an example. So suppose Joe randomly guesses at a true-false stats question. Joe's experiment has only two outcomes, right? So let's suppose that a success is guessing correctly and a failure is guessing incorrectly. Suppose Joe always guesses correctly on any true-false question with the probability of 60%. Then if the probability of success is 60%, then the probability of failure would be 40%. So we usually denote the success with little p, the probability, and the probability of failure we denote with this little q. Okay, so p is success, q is failure. So that means that for every true-false stats question he answers, his probability of success, p equals 6, and his probability of failure, which is q equals 0.4, or 40%, remain the same. This is an example of what we call a binomial experiment. These binomial experiments have these following characteristics. So first one is that there are a fixed number of trials. So meaning trials, you can think of trials as repetitions of an experiment. And the number of trials is denoted by the letter n, okay? And then there's only two possible outcomes. You can either succeed or fail. They're called success or failure for each trial. So like yes or no, they did or they didn't, true or false. So the letter P denotes the probability of success for one trial, and Q denotes the probability of a failure. If I add P and Q together, I should get 1, because that represents all the outcomes, because there's only 2. Okay, and then the trials are independent, and they're repeated using identical conditions. All right, so those outcomes fit a binomial probability distribution where X represents the number of successes obtained in n independent trials. So the mean, which is mu, the variance, which is sigma squared, this is a square, not O2, sigma 2, and the standard deviation sigma for the binomial probability distribution are, so here's the formula. Mu is n times p, so number of trials times probability of success. The variance, which is sigma squared, is npq, so just the product. And then sigma is the square root of the variance, of course. So these are three formulas you need to be familiar with. So if they say, oh, this is a binomial distribution, we need to know that these three formulas apply. Let's do an example, super fun example. So the state health board is concerned about the amount of fruit available in school lunches. 48% of schools in the state offer fruit in their lunches every day. This implies that 52% do not. What would a success be in this case? So a success would be a school that offers fruit in their lunch every day. Let's do another example. A trainer is teaching a dolphin to do tricks. The probability that a dolphin successfully performs a trick is 35%. And the probability that the dolphin does not perform the trick is 65%. Out of 20 attempts, 20 trials, you want to find the probability that the dolphin succeeds 12 times. How could we state this mathematically? Like, what symbols would we use? So it would look like this. So we're trying to find the probability that the dolphin succeeds 12 times. So x equals 12. Okay, let's do another one. A fair coin is flipped 15 times, and each flip is independent. What's the probability of getting more than, so than is the key here, more than 10 heads. Let x equal the number of heads in 15 flips of the fair coin. So x could be 0 heads, 1, 2, 3, all the way up to 15. Since the coin is fair, you have equal chance of getting a heads or tails. And the number of trials is 15. So let's state this question using symbols. We want more than 10, okay? Yes. So if you guessed P of x greater than 10, that's correct. So notation. So B is a binomial probability distribution function. It's usually written in this way. It's a binomial distribution, right? With n is the number, x is a random variable with the binomial distribution, and then the parameters are n and p, where n is the number of trials, and p is the probability of a success on each trial. Let's do another example. So it's been stated that about 41% of adult workers have a high school diploma but do not pursue any further education. So here's 41%. If 20 adult workers are randomly selected, find the probability that at most 12 of them have a high school diploma but do not pursue any further education. How many adult workers do you expect to have a high school diploma but do not pursue any further education? So then X would be the number of workers who have a high school diploma but do not pursue any further education. And what are the possible values of X? You could have 1, 2, 3, or up to 20 because we are doing this 20 times. There's only 20 workers, right? So the cap is 20. N is 20, the number of trials. The probability of success is 41%. And then the Q, the failure, is just the complement, which is 1 minus P, okay? And that's 59.59. So X is a random variable with a binomial distribution for 20 trials, and probability of success is 41%. So we want to find the probability of at most 12 of them. So if it's at most, that means that X has to be less than or equal to 12, okay? And I'm going to show this to you in how we did this using the calculator. Okay, so here's the example. Basically, I'm basically taking just the meat of it. So X is the value 0 through 20, where N is 20. The total numbers of trials is 20, and the probability of success is 0.41, so Q would be 0.59. It's a binomial distribution. If we want to find this X, probability of X equals less than or equal to a number, we use this function in the calculator called binom CDF. And we enter the number of trials, the probability of success for each trial, and then the actual value that we want to find, right? So for this problem, we would do, so this is what it looks like on the TI-84 Plus, where you have, we have to find a binom CDF, which is in second distribution, and I'm going to show you here on the next page exactly how to do it. Everyone, so this is when you want to get X less than or equal to. This is the binomial CDF function. So I'm going to show you how to do it just like how it was in the slide. So you go second, so the second key. Then you go here to vars because you want to really get the distribution. Okay. Then you go down to binomial CDF. Okay, so that's this one here. And you hit enter. Okay, and then in our case, the number of trials is 20. Okay, there's 20 trials. The probability is 0.41. Okay, and then the X value is 12. Then you go down to paste and you hit enter. You hit enter, and there it is. It's the probability of getting less than or equal to 12 is 0.9738. Everyone, so this is when you want to get X less than or equal to. This is the binomial CDF function. So I'm going to show you how to do it just like how it was in the slide. So you go second, so the second key. Then you go here to vars because you want to really get the distribution. Okay. Then you go down to binomial CDF. Okay, so that's this one here. And you hit enter. Okay, and then in our case, the number of trials is 20. Okay, there's 20 trials. The probability is 0.41. Okay, and then the x value is 12. Then you go down to paste, and you hit enter. You hit enter, and there it is. It's the probability of getting less than or equal to 12 is 0.9738. Okay, so I accidentally restarted. Okay, so another case is, what if we have the same situation, same scenario, same deal, whatever, and we just want to find the probability of getting exactly 12, equals 12, not less than or equal to, just equals 12. Then we would use this function in the calculator called binomial PDF, okay? So it's just we're going to call this up in the same similar way, and we're just going to plug in the same values, but now because we're using PDF, really have to stress this, it's a P, instead of a C, okay? So if it's equal to, we're using binomial PDF, okay? Everything else is the same. And let's go ahead and look at the video. The case where you want to find the probability that x is equal to 12, we're going to use the PDF, binomial PDF function, okay? This is a little different, but very similar. So second distribution, okay, we scroll down to binomial PDF, or A, hit enter. Okay, so we enter the same information. There's trials, 20 trials, right? Our P is 0.41, and then the X value that we're trying to find is 12. So you hit enter, and then paste, and hit enter again, and that's it. So that's 0.0417. Okay, so that's it for that. So let's go ahead and try that on video. Okay, so then that was basically the case that when you want to find the exact value of the probability of x equals some value. So then the final case would be, what if we want to find the probability that x is greater than, strictly greater than something? Okay, so let's suppose we have the same situation. We have n is equal to 20, p is equal to 0.41, and q is equal to 1 minus 0.41. We want to find x greater than 12. We think this, okay? Probability of x greater than something is the complement of the probability of x less than or equal to. So if we want to find the probability of x greater than a value, it's equal to 1 minus the probability of x less than or equal to. Okay, so what does that mean in the calculator is we have to use the CDF, but it's 1 minus binomial CDF. Okay, so I'll show you here in the next slide. The case where now for the fun case where, what if we wanted to find strictly greater than? So px strictly greater than 12. So notice that it's just greater than, it's not greater than or equal to. Let's use the following logic. So strictly greater than 12 is the complement of x less than or equal to 12, right? So it just means everything that's greater than 12. So we just go here. We're actually going to do the complement. So 1 minus second distribution. And then you go down to binomial CDF. Okay, so like before, enter 20.41. And the x value is 12. And then paste. So this is for x greater than 12. And there it is. Great. So the graph, if we were to graph this, it would look like this. You have all the cases, 0, 1, 2, 3, 4, 5, 6, 20. And so the y-axis would be the probability, where x is the number of workers who only have a high school diploma. And the number of adult workers that you expect to have a high school diploma but not pursue any further education is the mean, which is mu equals n times p, which is 20 times 0.41, which is 8.2. So the standard deviation is a square root of NPQ. So that's here NPQ, and that equals 220. Okay. So let's do this example. About 32% of students participate in a community volunteer program outside of school. If 30 students are selected at random, find the probability that at most 14 of them participate in a community volunteer program outside of school. So let's use the TI 83 or 84 calculator to find the answer. So again, you would do a binomial CDF, right? You would enter 30, 0.32, and then 14. Okay, so binomial CDF, 30, 0.32, and then 14. You can go ahead and try that, and if this is the correct answer, 0.9695, and you can check that with your calculator. All right, let's do one more super fun. All right. So same situation, and let's find the probability that 2 pages feature signature artists. So if you see this question, you have to ask yourself, is it an equal to, less than or equal to, greater than, what is it? So in this case, it's equal to. So we would use binomial PDF, right? Where we would enter 100, comma, and then P is just 8 over 560, comma, and then the value that we're interested in is 2, and then you would get 0.2466. Okay, so try the next one, sorry. The probability that at most 6 pages feature signature artists. Now remember, if the word at most means that 6 is the most possible, but it can be anything below that, okay? So it would be the probability that X is less than or equal to 6. And again, you would use different, right? This is PDF for when it's just equal to. This is now CDF, cumulative, right? Everything up to and including 6. So it's N is 100, P is still 8 over 560, but now your value is 6 because we're counting up to 6. And that's a high probability. Okay, and then the last one is, what's the probability that more than 3 pages? So mathematically, what would that look like? If you see P greater than, you're correct. P, X is greater than 3, which is equal to the complement of X less than or equal to 3. So then that's 1 minus binomial CDF. N is 100, P is 8 over 560, and then the value that we're interested in, not the number of trials is 100, is 3. Okay, so that's 1 minus 0.9443, which ends up being 0.0557. Okay, and then lastly, using the same formulas, let's go ahead and calculate the same situation. Let's calculate the mean and the standard deviation. So from earlier, do you remember what the formula for the mean is? It's NP, right? Which is N is 100 and P is 8 over 560. So that's approximately 1.4286. And the standard deviation is the square root. Square root key bothers me here. So this is supposed to go all over like this. Sorry, this is terrible. But imagine this is a straight line. Okay, so then that's equal to the square root of, it's all this, okay? Square root of all of this. Sorry, just pretend that that's a straight line. So N is 100, P is 8 over 560, and then Q is the complement of P. So 1 minus this is 552 over 560, okay? So this is N, this is P, this is Q. Take the product and then square root the whole thing, and it's approximately 1.1867. Okay. I have for you today, there is your super fun homework, and I will see you guys on the next video. Good luck studying for the exam, and please don't forget to work on the exam review that's posted on Newton for you. All right, see you soon. Now for the fun case where, what if we wanted to find strictly greater than? So Px strictly greater than 12, so notice that it's just greater than, it's not greater than or equal to. Let's use the following logic. So strictly greater than 12 is the complement of x less than or equal to 12, right? So it just means everything that's greater than 12. So we just go here. We're actually going to do the complement. So 1 minus second distribution. And then you go down to binomial CDF. Okay, so like before, enter 20.41. And the x value is 12. And then paste. So this is for x greater than 12. And there it is. Where you want to find the probability that x is equal to 12, we're going to use the PDF, binomial PDF function. Okay, this is a little different, so but very similar. So second distribution, and we scroll down to binomial PDF or A, hit enter. Okay, so we enter the same information. There's trials, 20 trials, right? Our P is 0.41, and then the x value that we're trying to find is 12. So you hit enter, and then paste, and hit enter again, and that's it. So that's 0.0417. Okay, so that's it for that one. So this is when you want to